Hello students, welcome to Saurav Sir's classes. The question is, when K population means in an ANOVA are truly different from each other, it is likely that the average error deviation for a significant F statistic are option A is relatively large compared to average treatment deviations, option B is relatively small compared to the average treatment deviations, option C is equal to the average treatment deviations, and option D differs significantly between at least two of the populations. Now, I think you all would be knowing what H0 and H1 are for an ANOVA. Well, H0 usually implies no significant difference, whereas H1 states that there is a significant difference. Now, as the means are truly different from each other, it means that the F statistic, that the calculated value of the F statistic is greater than the tabulated value of F statistic that is present in the tables. And we also know that the value of F statistic is given by the mean sum of squares due to a single treatment by the mean square of errors. Now, since this is large, since this F statistic is comparatively large, thus MSE would have to be comparatively small. So option B is the correct answer. The next question is, let A be a matrix which is 3, 2, 2, 1, 0, 1 and 4, 2, 3. Consider the following matrices. Now we have been given three more matrices which are P, Q and R. Then which of the following is correct? Option A, P only does not give generalized inverse of A. Option B, Q only does not give generalized inverse of A. Option C, P and R only do not give generalized inverse of A. Option D, none of the options is correct. So, first let us find out the determinant of A, which comes out to be 3 into 0 into 3 gives me 0 minus 1 into 2 gives me 2, that is 3 into minus 2 minus 2. 1 into 3 gives me 3 minus 1 into 4 minus 4 plus 2. 1 into 2 gives me 2 and minus 0 into 4, so 0. So this becomes minus 6 minus 2 into minus 1 gives me plus 2 plus 4. This is equal to 0. So A inverse does not exist. Thus, we need to find generalized inverse. Now, let us find APA, which is equal to A, replacing the values of P, 0, 1, 0, minus half, minus 3 by 2, this is plus half, not minus half, minus 3 by 2, 0, and then 0, 0, 0, replacing the values of A, 3, 2, 2, 1, 0, 1, and 4, 2, 3. Now, if we multiply these, we get this to be A into 1, 0, 1, 0, 1 minus half, 0, 0, 0, which is definitely not equal to A, because this needs to be a unitary matrix for this to be equal to A. Thus P does not give the generalized inverse of A, because if P would have given the generalized inverse of A, this would have been equal to A. Similarly, calculating AQA, you will replace the value of Q as we did for P, and then you'll replace the value for A, and you'll get QA to be 0, 0, 0, 1, 0, 1, minus 1, minus 4, and minus 7 by 2, which is again not equal to A. So thus, Q is also not the generalized inverse of A. Now, if we analyze the options, option A, P only does not give the generalized inverse of A. This is incorrect because Q also does not give. So option A is incorrect. Similarly, option B states Q only does not give generalized inverse, but it doesn't take into account for P. So option B is incorrect. Option C, P and R only do not give the generalized inverse of A. Well, we have not calculated for R, but Q also does not give generalized inverse. So option C is again incorrect. So option D, none of the options is correct. Here, since we have the options in such a way, we do not need to calculate ARA to come to the final answer. So option D is the correct answer. That is, none of the above options are correct.